Unit 7, Lesson 5, Negative Exponents with Powers of 10. So let's see how it happens when exponents are negative. Remember, your exponent is that top little number. So solve each of these mentally. 100 over 1 is equal to 10 to what power? Well, first, what is 100 divided by 1? That's 100. So 10 to what power is 100? 10 to the second power. So that means x is equal to 2. 100 divided by some value is equal to 10 to the positive 1. Well, 10 to the first power is equal to 10. So 100 divided by what equals 10, if I were to write that down? Well, 100 divided by 10 is equal to 10. 10 to the 0 power. So we've talked about this in the last couple lessons. When you raise something to the 0 power, you get 1. So something divided by 100 is equal to 1. The only way you get 1 when dividing, you divide a number by itself. So that means x is equal to 100 because 100 divided by 100 equals 1. Now it gets a little tricky. 100 divided by 1,000. Well, this, if we simplify it, we get 1 over 10. 10 to what power is 1 over 10? Well, we were getting smaller. We had 10 squared is 100. 10 to the first power is 10. 10 to the 0 power is 1. So if we're divided by another magnitude of 10, we now have 10. So x is equal to negative 1. 10 to the negative first power. Activity 5.2, negative exponent table. Complete the table to explore what negative exponents mean. So we have 10 to the third, which is 1,000. As a fraction, it's 1,000 over 1. 10 squared, as a decimal, is 100.0 and 100 over 1. 10 to the first power is 10. And as a fraction, it's 10 over 1. 1. Well, if we're using exponents of 10, that would be 10 to the 0 power is 1, which is equal to 1 over 1. So now we're getting into our negatives. Going this way, it was multiplying by a magnitude of 10. So like 10 to the 0 power times 10 is 10 to the first power. Times 10 is 10 squared. Times 10 is 10 to the third power. Going the opposite way, we are multiplying by 1/10. You may have thought, oh, the opposite of multiplying by 10 is dividing by 10. Those are the same. Dividing by the 10 is the same as multiplying by 1/10. So if we're going to take a magnitude of 10 away, I'm now at 10 to the negative 1. Okay, now if we're looking at our decimals to figure out what this would be, we're going left one decimal, went left another decimal, went left another decimal. So from here, when 10 is 0, that is our starting point. We're going to go left another decimal. So now I have 0.1. Or as a fraction, if we have 1 over 1 multiplied by 1/10, our numerator stays. And then we have 1 times 10, which is 10. Next one. If we multiply by magnitude of 1/10 and multiply by magnitude of 1/10, I'm now going to have 10 to the negative 2 power My decimal was moved another time or divided by a 10. I now have 1 times 1, still 1, and I have 10 times 10, which is 100. Okay. Multiplying by a magnitude of 1/10 again gives us 10 to the negative third power. Multiplying by 1/10 gives us 1/100th. Nope, 1,000. Tenths, hundredths, thousandths, and that gives us 1 over 1,000. So when we moved left, so starting on the right, which is backwards, going this way, we multiplied by a magnitude of 10. Our numbers got larger. When we went this way, reading correct from left to right, we multiplied by 1/10 or divided by 10. So times 1/10. How does the multiplier of 10 affect the placement of the decimal in the product? How does the multiplier affect the placement in decimal? So multiplier of 10, what happens to our decimals here? What happens to our number going from right to left? So right to left, we multiply by 10. What happened to our number? Well, our numbers were getting larger. Numbers getting larger. Well, when we went left to right, our multiplier was 1/10. What happened to our decimals here? Well, the opposite of multiplying by 10 is multiplying by 1/10. So our numbers are getting smaller. Numbers getting smaller. Use the pattern you found in the table to write 10 to the negative 7th power as a fraction. Well, if we look here, 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 100. 10 to the negative 3 is 1 over 1,000. So if we have to the negative 7th power, we're going to have 1 over, and this is 1,000, and this is negative 3. So this would be 1 over 10 to the third power. So this would be 1 over 10 to the 7th power, or 1 over, and then 10 to the 7th power is a 1 with 7 zeros. So 10 million. Use the pattern you found in the table to write 10 to the negative 5 as a decimal. So when we had to the negative 1, our decimal went 1 to the left. Negative 2, our decimal went 2 to the left. Negative 3, our decimal went 3 to the left. So negative 5, our decimal is going to go 5 to the left. 1, 2, 3, 4, 5. It's also equal to 1 over 10,000. Nope, 1, 2, 3, 4. 100,000. Write 1 over 100 million as a single exponent. So when we have our fraction, we have a negative exponent. Then how many place values? 1, 2, 3, 4, 5, 6, 7, 8 to the negative 8th power. Use the pattern in the table to write 10 to the negative nth power as a fraction. Well, up here, 10 to the negative third was the same as 1 over 10 to the power of 3. 10 to the negative 7th is the same as 1 over 10 to the 7th. So we're going to have 1 over 10 to the nth power. We're going to multiply 1/10 ever how many times our power is. Following the exponent rules. So when we have a power raised to a power, we multiply them, but we need to match them to the equivalent expression. So that's when we write it and expand it. 2 to the power of 10 is 10 times 10. And we need it 3 times. So we're going to have 10 times 10 times 10 times 10 times 10 times 10. The only one that has that is this bottom one. We have 10 to the power of 10, and we had 3 sets of it. This one we have 10 squared, all raised to the negative 1/3 power. Well, 10 squared is 10 times 10, and that's all raised to the negative 1/3 power. So if we were to rewrite it, we'd have it as a fraction, and we'd write it 3 times. So 1 over 10 times 10 times 1 over 10 times 10 times 1 over 10 times 10. Next one, we have 10 to the negative 2 power. So that is 1 over 10 squared 3 times. 1 over 10 squared is the same as 1/10 times 1/10. And that's going to be 3 times. So if we found this set 3 times would be right here. 1/10 times 1/10. And we have 3 sets of it. So the next one, we have 2 negatives. 10 to the negative 2 power is this right here. So 1/10 times 1/10, all raised to the negative 3 power. Negative 3 power means we're going to have this all as a fraction with a numerator, it's kind of hard to see, of 3 times. So we're going to have 3 sets of this. So here's 1 set, 2 sets, 3 sets. Write 10 squared raised to the negative 3rd power as a power of 10 with a single exponent. So this one, this one right here, as a single power. If we go back to lesson 3, I think, tells us we multiply our powers. So 10 squared times negative 3 gives us 10 to the negative 6 power. How many in this set 1/10 did we have? 1, 2, 3, 4, 5, 6. We could rewrite each of these as 1/10, 1, 1, 1, 1. We would have 6 of them. So this and this are equivalent. We can also prove it by doing all of our multiplying. So this first one is 1 over 100 times 1 over 100 times 1 over 100. And then we can expand it even farther. 1 over 1, 2, 3, 4, 5, 6 zeros. Part 2. Match each expression with the equivalent multiplication expression. So we need to expand each of these. 10 times 10. Oh, man, 10 squared is the same as 10 times 10. 10 to the power of 5 is the same as 10, 10, 10, 10, 10. So which statement looks like that? Well, it would be this one right here. 10 squared looks like 10 times 10. 10 to the negative 5th power is 5 1/10, because we would write it 5 times. The only one that has 10 squared on the top is this bottom one. And then we have 1, 2, 3, 4, 5 1/10. 10 to the negative 2 power is 1/10 squared, so we do it 2 times. And then 5 to the 5th power is 5 tenths. So we have 1/10 times 1/10, all divided by 5 tenths. 1, 2, 3, 4, 5. Last one, we have 10 to the negative 2nd power divided by 10 to the negative 5th power. So we have 1 over 10 to the power of 2 over 1, 10 to the power of 5. So we'd have 2 of these and we'd have 5 of these. The only one that's left is this very top one. Right? 10 to the negative 2 divided by 10 to the negative 5 as a single power of 10 exponent. So when we divide powers that have the same base, so we have 10 and we have a 10, we subtract our powers. So I now have 10 to the negative 2 minus negative 5. In 7th grade, when you subtract a negative, subtracting a negative is the same as adding the opposite. So we now have negative 2 minus negative 5, which gives us 10 to the 3rd power. If we were to look at this problem, and I'm going to, because this is the one that went with it, cross off those that are the same. So I have 1/10 times 1/10. So this and this. They are the same. So I now have 1 divided by 1/10 times 1/10 times 1/10, which is the same as 1 divided by 1/100th. So 1 divided by 1/100th is equal to, thousandths, 10, 100, 1,000, is the same as 1,000. Next, we have the multiplying powers. So when we have two values being multiplied with the same base, so 10 to the 4th times 10 to the 3rd, we add our exponents. When we write in expanded form, we write this expression, 10 to the 4th power, which is 10 times 10 times 10 times 10, 1, 2, 3, 4, times 10 to the 3rd, which is 3 tenths. So those two go together. 10 to the 4th, so we need one that has 4 tens, times 10 to the negative 3. So that means we would have 3 1/10ths, which gives us this top one. 10 to the negative 4th, so that means we have 4 1/10ths times 10 to the 3rd. Gives us this one. 10 to the negative 4th times 10 to the negative 3rd. So I have 4 1/10ths. Then I have 3 more 1/10ths. Write 10 to the negative 4 times 10 to the 3rd power as a single exponent. My rule, when they have the same base, is we add our exponents. So negative 4 plus 3. Negative 4 plus 3 is negative 1. So I have 10 to the negative 1 power. When I look up here at the expression, so this one, 1/10 times 10 is 1. And we can prove it. We will write it out. 10 times 1/10. When we are multiplying, we need both to be fractions just to make it a little simpler. And 10 over 1 is the same as 10, because 10 divided by 1 is 10. When you multiply, you go straight across, giving you 10 over 10, which is equal to 1. So if we cross one out, cross one out, cross one out, the only thing left is 1/10, which is the same as 10 to the negative 1st power. Lesson summary. Negative exponents with powers of 10. when we multiply a positive power of 10 by 1/10, the exponent decreases by 1. So 10 to the 8th power times 1/10 is 10 to the 7th. Meaning, when we are adding exponents, the only way to go from 8 to 7 is to have a negative exponent. So this is the same as 10 to the 8th times 10 to the negative first power to give us our negative 7. This is true for any positive power of 10. We can reason with a similar way. Multiplying by 2 factors of 1/10 decreases the exponent by 2. So we have 1/10 times 1/10, or a power of 2, is the same as 10 to the negative 2 times 10 to the 8th. Negative 2 plus 8 gave us our 6. This means we can extend the rule to use negative exponents if we make 10 to the negative 2 the same as 1/10 times to the power of 2. Just as 10 to the power of 2 is 2 factors of that are 10, we have 10 to the negative 2 is 2 factors that are 1/10. So our general rule is 10 to the negative nth power is the same as 1/10 raised to that power, or 1 over 10 to that power. Here's an example of extending the rule. So if we have 10 to the third power over 10 to the fifth power, we would then get 10 to the negative 2 power, because 3 minus 5 is negative 2. If we were to expand it, 10 to the fifth power is the same as 10 to the third power times 10 squared, because 3 plus 2 is 5. We are then able to eliminate 10 to the third power over 10 to the third power, because that's equal to 1, giving us 1/10 squared, which is equal to 10 to the negative 2 power. The same works when you have multiplying, because we would do 3 sets of it, which gave us 6 1/10ths. Homework. So our first one is when we are expanding, we want to go from expanded form to a single exponent. So our example is 1/10 times 1/10 is the same as 10 to the negative 2. So if I have 3 1/10ths, it would be the same as 10 to the negative 3. This would be 1, 2, 3, 4, 5, 6, 7. This is 2 sets of this. So if I were to write this one out, 1, 2, 3, 4. I have 10 to the negative 4 to the second power. Then I can use the next rule and multiply. So I have 10 to the negative 8th power. You need to try B, D, and E on your own. Write the expression as a single power. So when we have them like this, we add our exponents. Negative 3 plus a negative 2 gives us negative 5, 10 to the negative 5th. Add our powers, subtract, multiply, add, subtract. 3. Select all of the following that are equivalent to 1 over 10,000. So 10,000 is the same as 10 to the 4th power, or 10 to the negative 4th power. So let's see. This one also works. 10 to the negative 1, because if we rewrite it using our rule, it said we'd write it as a fraction raised to that power. 1 keeps it the same. 10 to the negative 4, we said worked. Negative 10 squared doesn't work. Okay, this one. We have 1 to the 100th power squared. 100 squared is equal to 10,000. So this one works too. Match each equation with the situation described. This is a review from Unit 3, Lesson 2. Try it on your own. And the next problem, question 5, is explain why triangle ABC and DCE are similar. This is a review from Unit 2, Lesson 8. And that is your Unit 7, Lesson 5 video.